All right, hi everybody. Welcome to the Sommers-Bausch Observatory virtual.
Erika, sorry. In action.
Hi everyone, welcome to the Sommers-Bausch Observatory virtual open house. I want to welcome you to our observatory on the campus at University of Colorado in Boulder. We have a team of astronomers here that will guide you through observations that we'll be taking here with our telescopes, looking all over the sky and all throughout the universe. We have both two highly experienced observers on our telescopes on campus, but I also want to let you know that throughout the evening tonight, you'll also be hosted by a group called the CU Stars, where STARS stands for Science, Technology, and Astronomy Recruits. And this is a group of undergraduate students. We travel all around Colorado, visiting schools and presenting all of these lovely things that we know about space, about astronomy. So as we get going for tonight, I'd like to first hand over the microphone to our observers at the observatory with the telescopes. So introduce your guys and introduce your telescopes.
Hello, I'm Daniel.
Hi, I'm Momo.
And we're grad students at the Astrophysics and Planetary Science Department here at the University of Colorado in Boulder. We're going to be guiding the telescopes tonight. And particularly, we're going to be using this telescope. Yeah. Can you guys see it? Oh, turn on the floodlight. Okay. So we're going to use this telescope that you see in the background. It is a 20-inch telescope that we use mostly for teaching, but tonight we're going to use it to show you guys a bunch of wonderful images of many objects. Anything you want to say?
So this telescope, its mirror is 50 centimeters. So, and your eye is only like 6 millimeters. So it can collect a lot more light. It's like very large. It's very large. Let me get the camera. It's very large, and it can collect a lot more light. So it can see very dim images, very dim objects on the sky that are very far away. And our colleagues tonight are going to introduce you to a lot of very distant objects throughout our universe. And we're actually going to use a camera that's very similar to the camera in your phone to collect light for a very long time. Usually your eye collects a light for a very short period of time, like a part of the second, whereas we're going to collect light for multiple seconds. And that's how we're going to allow to see very, very far away. We're going to be able to see almost a few million light years away, even if we point at Andromeda, if it seems nice. But yes, I don't want to promise too much, and I'm going to let you guys take it off from there.
So the lights. Yeah, so they get CU Stars. Now it's your turn to present yourself.
Okay, Noah, why don't you introduce yourself first?
Sure. Hi, I'm Noah. I'm a junior astrophysics major here at CU. I'm from Las Vegas, Nevada. I'm currently doing research in planetary science and specifically the Yarkovsky effect. And thank you all for joining us.
Christina?
Hi, I'm Christina. I am a sophomore astrophysics student here. I'm originally from Loveland, Colorado, and I am involved with variable star research here.
And Philip?
Hi everyone, I'm Philip. I'm a senior astrophysics student at CU, and I study supermassive black holes in numerical simulations.
And last but not least, Patrick.
Hello, my name is Patrick. I'm from just south of Denver in a town called Parker. I'm a junior astrophysics major in the department, and my research is mostly on the sun.
All right, we're here at the Stars to tell you more about the stars. On the YouTube live stream, if you're joining us live, you should be able to type questions in the YouTube chat window. And if you do that, we'd be really happy to answer any questions you have about what we're looking at or anything about the cosmos. I think the stars will be able to answer all of your questions. There may be a many-second delay in time between what you hear and what we're talking about. And so be a little patient on the chat window, but be sure to let us know. If you do have the chat window up, if you are from one of our host schools, a school that we visited, if one of your teachers has told you that you better come and join us, write the name of your school in there and let us know that you're here. So the first object we're going to be looking at is one of the brightest ones you're going to see tonight in the sky. It is the planet Mars. And so I'm hoping that Momo and Danielle can move the telescope around the sky and point directly at the red planet. And then we'll just hand it over to Noah, who is our Mars expert tonight.
Okay, so we are at Mars now. And
how we do this?
So
What you're seeing right now on your screen is the computer program we're using to control the telescope. What you're seeing in the background is a map of the sky. As we have maps of the ground, like maps of Earth, we have maps of the sky, and we can just point on our computer where the telescope should go, and it follows our orders pretty easily. And that's how most modern astronomers control their telescopes. So,
yeah, the telescope also is very good at keeping up with the rotation of the Earth. So a manual telescope, you always have to be tracking the object. And we're going to see when we take very long exposures, that is, when we have the telescope pointing at the object for a long time collecting light, there's going to be no jitter at all in the object, which means that the telescope is fixed. But to be fixed at the object, it has to actually rotate what we call slew a little bit. So these are impressive telescopes.
they're very nice.
Yeah. And okay, should we take the picture first, Noah, or do you want to start talking? Okay. So
Go ahead and take a picture first, and then I'll start talking about it.
okay, perfect. So here in the software for the camera, you see that there's this exposure time bar, and here we control how much light we collect from the object, right? Which is in turn going to translate with the object looking very bright or not. Because Mars is normally a bright object, given that it is a planet and it is close, we have to have a very low exposure. So we're actually going to go to the lowest exposure that we can do, which is a thousandth of a second. So here's Mars. Here I'm just trying to use the contrast to see less of the sky. There's still some light in the sky. And I think this is a good pick. You want us to take another one?
I think that's good.
Should we try this back?
Do we see other stars? Yeah, I think this is okay. Later, you know what we could do? We could try a very high exposure to see if we can see a moon.
Go ahead, try that, and I'll just start talking.
Okay.
So, all right. So, talk about Mars for a little while. It's a pretty interesting place. So Mars is the fourth planet from the sun. It's named after the Roman god of war. It's the second smallest planet after Mercury. It's about half the diameter of Earth. It's got two moons, Phobos and Deimos. It takes 687 Earth days for it to orbit around our sun, so it has an extra long year. But a day on Mars is very similar to our day. It's a 25-hour day compared to our 24-hour day. It also has very similar seasons to Earth. That's because the tilt of the planet is very similar to ours. However, Mars is not really a nice place to live. The average surface temperature is negative 93 degrees Fahrenheit. And also the atmosphere is mostly composed of CO2. Also, the air pressure at the surface is only a small fraction compared to the pressure on Earth. So yeah, not a great place to live. Mars is also called the red planet, of course, and that it's red because of iron oxides that cover its surface. And iron oxides are basically rust, so it's basically a giant rusty planet. Mars also has these really big dust storms that can cover almost the entire planet for months at a time. It also, on the surface, it has the largest volcano in the solar system. It's about 3 times the height of Mount Everest. And the way it's called Olympus Mons, by the way. The way it formed is from lava flows that basically went on the surface and then cooled over time. And these lava flows basically just stacked up over and over again over a really long time. And that's what formed this giant shield volcano on the surface. So the big question we have about Mars is if there was once life on it. We know there was once water on Mars. We have evidence that there was liquid water. Right now, liquid water can't exist on the surface because the air pressure at the surface is way too low. It'll boil immediately, basically. However, at the poles and in certain minerals, there is water still there. So we've sent now 5 rovers to the surface of Mars, try and figure out some of the mysteries we have about this planet. And the current one that's currently moving around the planet is Perseverance. That just landed a month or 2 ago. And so I'm going to talk about Perseverance for a little while. So if I could share the screen real quick. All right, so first I'm going to share. There we go. So I'm going to share this video. This video is, it shows Perseverance descending to the surface of Mars. This is the first time we really have footage like this of a spacecraft landing on a planet like this. So it's pretty cool. So let me play it. Sorry, there wasn't volume there. You can just go look up the full video on YouTube. It's pretty cool. So now Perseverance is on the surface, rolling around, and NASA uploads a bunch of pictures it takes, and you can find them here on this website. And this right here is really cool. This is the Ingenuity helicopter, basically. So what they're doing is they're placing this little helicopter on the surface of Mars, and they're going to launch it remotely. Again, this is the first time something like this has ever been done on a different planet, so that'll be really cool to see. It also has a couple other instruments attached to it. They're going to perform different experiments on the surface. Two of them I'm really interested in are the Super Cam and Moxie. So Super Cam is basically this, as it says here, laser micro imager. It's going to observe the surface, figure out the composition of what's in the rocks and stuff, and it's going to see if there's organic matter, which is a sign of life. So that'll be cool. And Moxie, this experiment is going to try to produce oxygen from the CO2 in the Martian atmosphere. Obviously, that's going to be really important for future manned missions to Mars, for future settlements on Mars. So that'll be really cool to see how that works out. And yeah, so keep an eye out for what Perseverance is doing. And if you have any more questions on Mars, put them in the chat.
That's great. Our next object we're going to be going to is the Orion Nebula, and Christina is going to tell us a little bit about this. It'll take a moment to slew the telescope, to move the telescope to Orion, and then to take maybe a 30-second exposure. The longer the exposure, the more detail we're going to see, and then hopefully we'll be able to see this beautiful nebula in the constellation Orion.
So very quickly, we took a very long exposure of Mars while Noah was talking to see if we can see a moon. I've actually seen a moon before, and no moon. Basically, we have these speckles here, which we think there are stars. So yeah, we couldn't catch the moon today. It takes a very long exposure in order to see the moon. Okay, so yeah, next up is Orion's Nebula. So let's go there. So here, the computer is going to tell me where Orion Nebula is. It's right down here. And this orange line is actually the window we have in the sky here in the observatory. And the red line is the window we have in Boulder. So basically the night sky right now that we can see, everything that is outside of this green window is we can't see from Boulder right now. And we can see that Orion's Nebula is actually getting closer to this horizon, so we should go there now. And now we take the exposure of 60 seconds.
Okay, so the Orion Nebula is a molecular cloud. It's actually one of the brightest nebula in the night sky and one of my personal favorites. So what you're going to see when the image comes up is that we're seeing light that is reflected off of these giant clouds of dust and gas that are in space. And molecular clouds are star-forming regions. So sections of these nebula will start to clump together. And as they get clumped more and more together and the mass increases, the temperature is also going to increase. And that's what leads to fusion, which causes these young stars to shine. So once the image pulls up, hopefully we might be able to see there's 4 central stars in the nebula, which are called the Trapezium. And they're actually an open cluster of young stars that have formed within this nebula. So I see we have the picture pulled up. So yeah, again, we're seeing the light that's reflected off of the dust and gas that's up there, mostly hydrogen and helium. So if you have any questions about that, throw them in the chat and I'll happily answer.
So here we're going to change the contrast of this picture. And this may emphasize the brighter objects that right now are being covered by the nebula's light. So look, I found something there. What's that?
So you can see in the center the 4 trapezium stars that Christina was talking about. And so those are the stars that have just been born in the nebula and whose energy is really shining a lot of, well, it's pushing out a lot of energy into the nebula. And it's one of the reasons that the nebula is so bright and shining, is from the light of the energy of these brand new baby stars. So we'll get set up in just a moment for the next object we want to look at, which is a galaxy. In the meantime, the Orion Nebula is one of the brightest nebulae, one of the brightest fluffy things in the sky. It's so bright that on a really dark night, in a really dark place, maybe up in the mountains of Colorado, what you'll see is the Orion Nebula, very, very faint, out of the corner of your eye. You'll be able to see it with your eye, even without a telescope.
So right now we're pointing the telescope at our next object, which is a galaxy, and it has this complicated name, NGC 2903, which is basically a catalog number, which is like the galaxy has a catalog number 2903 in the NGC catalog. And I think Philip is going to tell us more about it.
And for this galaxy, we're going to start the exposure at 1 million. Probably we're going to need to increase that.
Hi everyone. So I'll talk a little bit about this galaxy, which is a little far away from where we are. So like our Milky Way galaxy, this galaxy NGC 2903 is also located within the Virgo supercluster, which is a supercluster containing a lot of galaxies. And when the picture that they are taking right now is showing up, we're going to see a fabulous barred structure that you can see the spiral arms, and you can see the like a bar structure at the center, looking like a Milky Way bar. And this galaxy, like Momo talked about, is cataloged. That's why it has the NGC name in front of it. And this galaxy was cataloged by William Herschel on 1784, so which is like 200 more than 200 years ago. And you can see that this galaxy has these pinwheeling arms, and there are a lot of stars. You can see the bright regions. You can see the glowing gas, which are areas of star formation. Like there are a lot of star forming on those regions. You can also see the dark part of the galaxy. If you can adjust the contrast a little bit, probably the spiral arm structure will be more apparent. So this galaxy, like ours, is not very active. it's not forming stars very rapidly. In fact, it's forming about less than one sun per year. And you can, yes, great. So now you will probably see the pretty structures, the spiral arms and the spiral arms that's the gas emitting radiation, and the dark parts, which are the dust blocking light. So now I will hand this back to Patrick, and he will talk about another cluster.
So next up should be NGC 1893. I'm not sure what the how the exposure is going on that one, but this one's going to be an open cluster, which is similar to the Orion Nebula. You should be able to see the reflection of light from newborn stars, similar to the way of what we saw in Orion's Nebula. Just some facts about it. It's about 12,000 light years away, which means that the light that we'll see tonight was actually released from the cluster about 12,000 years ago, which far predates anything that we can ever comprehend. But for the age of this cluster, it's about 4 million years old, and that's pretty young in the scheme of things for open clusters. It contains about 4,600 stars in it, and from edge to edge, it's about 100 light years across. When we get an image of it, we should be able to see two places in the cluster that are more prominent in star formation. If not, I have a quick image I can pull up. But as we talked about before, in open clusters, all the stars are born from the same cloud of gas. The stars in the cluster usually have about the same age since they were born from the same cloud. And this is really interesting for a lot of science that goes on, because some of these stars we see in different parts of their lives. And so because they were born around the same time, but they are in different stages of their lives, we can see how different properties of these stars might affect how long they live. And that's where scientists look to see a lot of star evolution. So yep, we can see here this is the star cluster. You can see a lot of stars, as you'd imagine, because a lot of stars were born from the same cloud. They're on the same spot. You can see in the center there, that's going to be where a lot of the stars were born. And then it gets a little more sparse as you go out because the cloud dissipates a bit. And within those regions, there's still star forming potentially going on. And you'll see a lot of young, bright stars. And that's kind of it for this open cluster.
Right, observatory. Are we on the next object or about to be on the next object?
We're getting there. We got distracted looking at the picture. So I'm guessing a 1 minute exposure.
Okay, this one I think is for Christina. Give us the story.
It is indeed. All right, so whereas the other nebula we looked at was a star-forming region, this one is not. This is a completely different object. So this is actually going to be a supernova remnant. So for some of the bigger stars, when they get to the end of their life, they undergo a supernova event where the pressure from fusion is no longer able to keep up with gravity. And so everything just kind of comes in and it bounces off and we get this huge explosion in space. And that's what we're about to look at. So usually it'll leave behind like a neutron star or a black hole surrounded by this very hot gas from this explosion. And actually this particular star, when it went supernova in 1054, it was bright enough to be seen during the daytime for a couple of weeks. And the really interesting thing, I think, is that it was very well documented by Chinese astronomers who sometimes refer to supernova as guest stars. And these were considered either a good or a bad omen. So for this particular supernova, it was considered a sign that the emperor was doing a good job. The other very interesting thing is that there aren't any European records. So maybe it was just cloudy for a couple weeks. Maybe nobody was paying attention. We're not really sure why. But it's possible that this event was even documented by some petroglyphs that could be seen in the Chaco Canyon. There are these images on the rock of a hand, a crescent moon, and a star. And some people think that this is a depiction of this supernova event. But again, we can't really be sure. So yeah, so this is our Crab Nebula. So that's hot gas left over from the end of the star's life. So again, any questions? Please let me know. I'll try to answer.
Christina, I have a picture of the petroglyph in Chaco Canyon that you're referring to. May I share the screen?
Absolutely.
Great. All right, you should be able to see a screen now showing really an overhang of rock. This is in Chaco Canyon in northwestern New Mexico. This is a place that was a center of the Chaco civilization, ancestral Pueblans, who lived there about 1,000 years ago. They were incredible astronomers. They built their houses to the stars and the sun and the moon. And we believe that they must have seen the supernova really at the heyday when they were living in this canyon. What you see is a crescent moon. It was a crescent moon that night, a hand. And then also in the lower left, you see what some people think might be a record of a supernova, a bright new star in the sky. This is still pretty controversial because there are these sorts of symbols that you see in rock art all over the Southwest. And so perhaps this is a supernova record, perhaps not. It is something that was painted on rocks by people who did watch the sky. How are we doing on the next image? Have you taken another image of the crab?
Yeah, so we take a long exposure. We're taking a 2-minute exposure now, so this is twice the time as before. And let's see if we see anything different.
Oh yeah, it's better.
It's a really nice image you guys have there. That's fantastic.
Yeah.
You can try.
No.
Yeah. All right.
Do you want to try a longer exposure?
Oh yeah, great one.
So next up on our list is going to be M81, which is a galaxy. The colloquial name is Bode's Galaxy. It's a galaxy that is a spiral galaxy similar to ours. It's about 12 million light years away. So much further out than some of these other objects that we've been looking at. At 12 million light years away, that's 12 million years ago that the light was emitted from the galaxy. Some statistics about it. About the diameter of it's about 100,000 light years across, the 90,000 to be more exact, and the proximity, the proximity to our own galaxy, the brightness of it, the size of it, as well as the black hole that's in the center of the galaxy, makes it a very popular object for both professional and amateur astronomers. The Hubble telescope has taken some really nice photos of the galaxy, and you can look those up on the internet, and they're truly amazing. The galaxy's spiral arms, as we talked about, I think in a previous object, that's where a lot of the star formation occurs. And you should be able to see some of those arms on the photo that we take. Yeah, and so in the center of this galaxy is, as with most other galaxies, is that there's a central black hole, and that kind of keeps the structure of the galaxy together, and it dictates a lot of the structure. And the galaxy's central portion is where a lot of the older, more red stars are, and it's actually a lot larger than our own galaxy's center. The black hole at the center, just for some statistics, if any of you guys would like to know, it's about 7 million solar masses, which is massive, as in the name, but it's about 15 times the mass of the Milky Way central black hole. And so that kind of creates some interesting contrast between our own galaxy and this one. And so we can kind of see in the images that we're pulling up here, you can see that central bulge right there with a lot of bright stars. And as we change some of the characteristics on this image, you should be able to see maybe some of the spiralness of it. But yeah, one of the main features of this galaxy is the large, bright center to it. And that makes it interesting to study. A lot of professional astronomers study it to look at how galactic centers work compared to our own. So yeah.
Are we getting ready for our next object? Are we getting ready for our next object?
Yes, we are just new to our next subject, M82, and we are taking a 2-minute exposure for this one.
So I'll take this one. We just moved the telescopes to a galaxy called M82, and you might have heard that a couple of these objects are called M this and M that, and the M stands for Messier, in particular a French astronomer from the 18th century, Charles Messier, who at the time, what astronomers did to make money and to become famous is that they found comets. And so they swept the skies with their telescope looking for comets. And what they found often were these little fuzzy things. These fuzzy things were such a nuisance that Charles Messier made a list of them so that they wouldn't be fooled over and over again, thinking that there was a comet there. If you found a comet, you got a gold medal and probably a job for life as a court astronomer somewhere. So in any case, he made this long list, and we keep this list now because we find that these little nuisances turn out to be some of the most beautiful nebulae, clusters, galaxies, all of the supernova remnants, all of these remarkable things in the sky. So we just looked at M81. This is M82, this will be M82, which is a galaxy located quite close to M81. They're actually neighbors in the sky, although they are separated by millions of light years. M82 is unlike most galaxies out there. Instead of being one of these great big beautiful spirals that have spiral arms with star formation in them, M82 is called the Cigar Galaxy. And it's actually a galaxy that is being disrupted. So the gravity of M81, its neighbor, is actually pulling this galaxy into some funny shapes. There we go, the Cigar Galaxy. And so if you look carefully, what you'll see is that it actually looks like it's divided in the center, and there are these really, really bright dots on either side. These bright dots are places where there are lots and lots and lots and lots of stars forming. It's, this is a galaxy that's called the Starburst Galaxy. And what's happening is that as the gravity of M81 sweeps over M82 like a wave, it compresses the gas and the stars in this galaxy. And it's causing a huge amount of stars to be formed and actually an explosion going off into the galaxy. You can't see it in this picture or even with visible light, but there's huge, huge rays of gas being blown out of the center of this galaxy. So these starburst galaxies are relatively rare, but we think that many galaxies, when they are bumped, nudged by some neighbor, will actually go into a phase where they just use up all the gas, making a huge pile of brand new stars. So M82 it's got this nuisance name, but it's actually a pretty remarkable galaxy. So it looks like we're slewing to another object. Let us know when.
I think the Butterfly Nebula that was going to be our next object is a little bit under the horizon, so we might just jump to the next one on the list.
This is over here.
Oh, yeah.
Yeah. I'm guessing this is the planetary nebula you're referring to.
Yeah.
M37. Okay, so instead, we're going to go to M37, which we can see it is in the window of our telescopes.
And since M37 is an open cluster or just a collection of a lot of young bright stars, we don't need to collect light for a whole minute. We can do it even a bit faster.
Wow.
There we are.
This is out of focus here.
Right, I think this one is for Patrick.
This is M37. And so with this object, we have M37. This is a open cluster, and it's about 350 to 550 million years old. And in comparison to some of the other clusters, that's very, very old. For some comparison, one of the open clusters, or one of the other clusters we looked at, was about 4 million years old. So this is significantly older. It's only about 4,000 light years away, and it's about 20 light years across, and has over 500 stars in it. And it was initially observed in the 18th century, and it was actually missed by a few other observers before. It's next to a few other Messier objects, but it was kind of passed over. But when one Royal Navy officer saw it, he actually noted in his journal, he said it was a magnificent object, the whole field being strewed as if it were sparkling gold dust, and the group is resolvable to about 500 stars. And so this cluster is opposite from the galactic center from Earth. So on one side of us is the center of our galaxy, and on the other side is this open cluster. And so we see it a little more, I guess a little better, because we don't have a bunch of the light from the center of our galaxy kind of shading it. And it has a bunch of old stars, and it looked like some of the other clusters we had, but the center part there has a bunch of old stars in it. But yeah.
Right, I want to check with the observers. Our next object is called the Intergalactic Wanderer. Have you been able to get the telescope pointed there?
Yes, we are pointing and taking an exposure right now.
Right, I think Philip is up here to, why don't you tell us a little bit about what you mean by galactic and what you mean by intergalactic?
Okay. So this is an interesting cluster because it has the name Intergalactic Wanderer. And intergalactic here means that it's not a member of our galaxy, which means that it's not bound to orbit the center of our galaxy. But actually, this name is mistakenly given to this cluster. In fact, it is actually indeed a member of our galaxy. And like the previous object that I talked about, this is also in the NGC catalog. This is called NGC 2419. And this is not a galaxy, but a globular cluster. What it means is that, that this is a collection of stars, like the one Patrick was talking about, but instead this one is will look very spherical, looks like a sphere. And it has a lot more star when compared to an open cluster. Why this has the name intergalactic is it's because it's very, very far away, and it takes about 3 billion years to finish a complete orbit around our galaxy. And as we are looking at the image here of this this cluster, it is actually light that it was emitted 300,000 years ago. So it's when you look at this cluster, you will see that it has the spherical shape, and it has a very densely populated central region. So when the contrast ratio is adjusted, you should be able to see much more stars close to the center. And it is said that if there's observers from Andromeda Galaxy, which is another galaxy very close to us, they would be able to see this very, very bright cluster orbiting us. And that would be an ideal cluster for them to observe that's inside our galaxy.
Right. What comes next, guys? Are we on our way to our next object?
Yes, we just pointed the telescope toward the Messier object 106, which is a galaxy in a galaxy in the very small constellation called Hunting Dogs. It's right. Actually, that constellation is right behind the big bear, because the Big Dipper, and the constellation of Big Bear is because actually they're hunting the bear, and we're collecting light right now from that galaxy, and we're going to show a picture in a second. It's a spiral galaxy like our own Milky Way, so it kind of looks like our own Milky Way, as can be seen if we can see it from top, not from inside as we are. And yeah, you can see it here. It's pretty cool.
So I have some more info on it. I'll share. So yeah, it's a Messier object, even though it was discovered by Pierre Méchain. I'm not sure if I'm saying that name right. It's French, and it was discovered in 1781 by him. It's about 22 to 25 million light years away, and is actually one of the largest and brightest nearby galaxies, comparable to Andromeda. It has an active nucleus, so that means there's a supermassive black hole at the center. One of the really cool things it has is something called the water vapor megamazer. A maser is basically a laser that emits light in the microwave range of light. So basically, this water vapor in the galaxy is heated up evenly, and it releases a certain wavelength of light that beams towards our planet. It's a bit different than how a laser works here on Earth, but the end product is basically the same. So that's pretty cool. Also, the water vapor in the galaxy is what gives it its purple color in color images. So maybe go take a look at that too to see that. That's pretty interesting. Yeah.
Yeah, I think we're doing the tour of the galaxies here. We have another beautiful galaxy now. Can we get there, guys, or is it too close to the horizon?
Yeah, it's right past the horizon. Yeah, you can see it here.
Okay, well, we can stop that for a minute, and could we please go to the beautifully named Butterfly Nebula?
Didn't we do that already? Yeah, we already tried the Butterfly Nebula, and it's also outside the range. Maybe we can try. It's very close, so the telescope is.
It's basically going to be behind the roof, I think, right now for us. Right now for us.
Yeah.
Right.
And we could risk watching something that's low because this is high. We don't want to have the telescope flipping.
Okay, then going down our list, one of our last objects of the night would be the nebula called the Ghost of Jupiter.
Sure.
All right, so while they're working on the image of that, I'll talk about it for a little bit. So it's called the Ghost of Jupiter, which is a pretty cool name. It's called that because when you look at it through a telescope, it's about the same apparent size as Jupiter. So if you look at it in the night sky, it has the same size as Jupiter. So it's going to be a planetary nebula, which, unlike a supernova nebula that forms after a star like our sun dies, and it'll basically just slough off its outer gas and form this giant nebula. What remains in the center is a white dwarf core that's really small, also really white hot and bright. It was discovered by William Herschel in 1785. It's also called the Eye Nebula, and hopefully we'll be able to see why it's called the Eye Nebula in the image comes up. But if not, then I recommend looking up an image on the internet to see why it's called the Eye Nebula too. Also, the two ends of the nebula, there's these jets of gas basically moving out from the ends of the nebula, which you can also see in images online. And that comes from just how the gas from the dying star shoots off into space.
I think that's it. It's just you can see how much bigger than a star it is. Like you can compare it to other stars in the field of view, and it just looks bigger because it's actually it's significantly bigger, and you can see its physical size, and it's similar size to Jupiter, as we already mentioned. Yeah. If you pull to the other side. No, to the right. Yeah, pull. Yeah, you can start seeing now with changing the contrast of the image a little bit, how the central parts of it are not as bright as a star. And yeah, it looks like Jupiter. Okay.
So now we have navigated to M87, which is another galaxy, and it's also part of the Messier catalog.
Yes, I'll have a lot to talk about M87 because this is the galaxy that I do the majority of my research on, and this galaxy is one of the most famous galaxy that we know because of its fabulous jet, and this galaxy is also very, very massive, and it's not like any of the galaxies that we have looked at tonight. So it looks very elliptical because it has been through many of the collisions with other galaxies. And at the center of the galaxy is a supermassive black hole that weighs 6.5 billion times the mass of our sun. So when compared to the galaxy to the supermassive black hole at the center of our galaxy, this one is much heavier. And this black hole is the first one we were able to take a photo of to see what a black hole really looked like. And I think Erica has the image. So looking at this black hole, you can see many features here. So the black hole is located at the center part of this of this photo inside the central shadow. And you can also see that light is glowing around it. That's because of the accretion processes happening around the black hole, because mass is being accreted into the black hole, and it produces heat with friction and radiation. And you can see one side of the black hole is actually brighter than the other side. That is the effect of Doppler beaming, which means that the light coming towards us seems brighter than the light is receding from us, which is dimmer. And this image is actually very, very meaningful because it confirms many of the predictions from Albert Einstein's theory of general relativity. And that was 100 years ago. And after Einstein published his general theory of relativity, Karl Schwarzschild obtained the solution of a black hole. And after that, we also have a spinning solution of a black hole, which means that the black hole is very, very massive, very dense, and it's spinning. So this image confirms many of the predictions from 100 years ago, proving Einstein right once again. And you can see that there are like these lines on the black hole image. Their results released just 2 weeks ago about what the black hole's magnetic field looks like. So yeah, this is what a black hole looks like if you go very close to it and use your phone to take a photo.
That's great. I don't expect our image of M87 is going to look nearly as nice as the one that took the resources of many astronomers and many telescopes, but there we go. And so you can see that, Philip, if you wanted to relate what we're seeing here from the observatory screen to the image that we just showed, showing the central black hole, how big would it be? Do you have a feel for that?
Oh, it would be tiny, I think. The black hole would be very tiny. I don't think you can see it.
Mm-hmm. So looking deep, deep down into the center of the galaxy.
Right. And there are a lot of dust that's blocking what a black hole really looks like. That's why the black hole image you saw was taken at 1.3 millimeter wavelength, which is radial wavelength. And this photo is taken in the optical wavelength, which means the wavelength that human eyes can see. So it's taken in a very different frequency and wavelength of light.
Okay, well, I think we're about out of time right now for our virtual star party. This has been a trip that took us from our near neighbor Mars out to galaxies millions of light years away from us, with some good stops in places where stars were born, places where stars die. And so we hope you've enjoyed being able to look at the stars with us, sharing our beautiful telescopes. If you come to Boulder, once we are back live and in person, the observatory has open houses nearly every Friday night that are open to the public and free. And so keep an eye on our website for when we are able to open up, and you'll be able to see with your own eyes these same wonders of the universe. So thanks for joining us. I want to have a big thanks to Momo and Danielle for moving the telescopes, taking the pictures, guiding us through the skies, and also a really big call out to the CU Stars. Thank you for sharing all your knowledge and all your enthusiasm for the things we see in space. So that's the end of our virtual open house, and